Okay, welcome to Informatics, the ACIO, Australian Community Informatics Olympiad. So this is a practice run for the Australian Informatics Olympiad, which happens in late August, created very generously by, I believe, some students, just to give an opportunity for the competition experience. And so I'm recording this video so that novices can see what the competition experience looks like. So this is the screen you see when you log in to the competition webpage, and this is exactly what the AIO would look like. When I click start, my 3 hours will begin, but before I do that, I'm going to click on rules and documentation. And I won't go through all this in complete detail, but this is something that you need to know. You're not allowed to look at other websites when you do this, but you are allowed to look at reference for your preferred programming language. So I'm going to open this in a new tab. This is a Python reference. A bit slow. So there's all sorts of information here. 90% of it no use to us, but if our library references could be a good thing. Okay, the library reference, it contains a lot of information about how to use things that come with Python, like dictionaries, sets, strings, and so on. So you can look up, like if you need to do something with strings and you're not sure, you could have a look at that. Regular expressions could be good. Extra string operations. Anyway, it's good to be aware of this. 90% of this completely irrelevant to an informatics competition. All right, I'll keep that there in case I need something. All right, I'm going to go back. Unfortunately, things are very slow. And I'm going to start. Okay, so this is the contest page. So it tells me how much time I have left. So I've got 3 hours. Here's problem 1. You get the details, and then here's how you submit a solution. Problem 2, problem 3, up to problem 6. You can look at rules and documentation there. We've already done that. This task overview, we don't need. It doesn't have any information that's not stated in the problems, but it's just a little summary, I suppose. If you need to ask a question during a competition, then you can do that here. And so there's a couple of announcements, something related to questions 3 and 4, saying that the answer might be a really large number. So for certain programming languages, you need to be careful about that. For Python, it's fine. So you can type in you can type in a question here if you need to ask a question of the competition organisers. All right, so let's get into problem 1. Now this video is going to have really introductory, intermediate, and slightly harder intermediate content in it. It won't get into anything advanced. I have looked at these already. I actually tried to record a video yesterday and then had a technical problem. So this is take 2, which is good in a way. It'll be quicker than take 1. But I want the video to give novices an opportunity to see what it's like to read a question, to think about how to program it, to submit it, to make mistakes, to correct them, and so on. It'll give you a really big introduction so that you can take part in it next year. Right, so there's a problem. Problem 1 is called sandwich holes. I'm going to download the task statement. The details here, the time limit is 1 second, memory limit 256 megabytes. It's only when you're doing advanced things that you'll care about the memory limit. and the data will come in an input file called holesin.txt, and I need to write my answer in a file called holesout.txt. That's the way that the website judges my submission, because it sends a whole bunch of inputs towards my program, and it sees if I give the correct output. Okay, so download task statement. Okay, we're getting a PDF here. Okay, so the problem statement is a nicely formatted PDF. Just scrolling through there. Okay, so it's 2.5 pages. I'll zoom in, and then I'm going to be quiet for a bit while you read the problem statement. Okay, so the problem statement is really verbose, has a lot of irrelevant context, and this is deliberate because it's up to us to read it and work out what we need to know from it. Fundamentally, there's cheese in a sandwich. We don't like cheese, so we get to poke holes in the sandwich with a toothpick to see if there's any cheese in there. And our question, what is the minimum number of holes you need to poke so that you can be absolutely sure the sandwich has no cheese in it? The input has 2 integers, the length and width of the sandwich. So in sample 1, it's a 3x3 sandwich. Everything's in centimeters, I guess. So a 3x3 sandwich. And the cheese that's on there is a 2x2 piece of cheese. So we can see in the diagram down here, so there's a diagram for sample 1, that there are 4 places that the cheese could possibly be, right? 4 places that the cheese could possibly be. And in all 4 places, it always occupies a center square. So you only need 1 poke of the toothpick. If you judge it well, if you only need 1 poke of the toothpick in the middle to see if there's any cheese in there. Sample input 2, it's a 2x2 sandwich, and the cheese is 1x1. So that means there's going to be 4. Here's sample input 2, 2x2. There are 4 places the cheese could be. There's no overlap, so we have no choice but to poke it in 4 places. All right. And when I read this yesterday, I still didn't know exactly how I was going to answer this question. It is quite easy, and I'm going to move quickly just for the sake of the video. But it was sample input 3 where they don't provide a diagram that helped me the most to understand how I was going to do it. So if you can picture, I can't show you, but if you can picture a 10x4 grid, that's a sandwich, and the piece of cheese is 3x2. So there's an awful lot of places the cheese can be. But how many are there? Well, if we work against, say, the top left corner, then you can put 3 pieces of cheese next to each other for a width of 9 and then have 1 gap. And so that's the 3 going into the 10 3 times. And the 2 goes into the 4 2 times. So if you spread it out, then you've got, like a piece of cheese here and no, I can't use that diagram, but whatever. You can layer 2 pieces of cheese, one above the other, not on top of, but like above on the sandwich. There's only one piece of cheese on the sandwich. The question is, where could it be? I think the best way to look at this is like an adversarial point of view, like the cheese is spread out, like the potential cheese is spread out as much as possible. How many possible places could we prick to do it? So I don't think that made much sense. Let me try again. Look, basically, well, we just need to know horizontally, you can fit in 3 pieces of cheese without any overlap. There's a little bit of room left at the right there, but that doesn't really matter because it means that the cheese could move over a little bit, but it would still be there. And vertically, you can fit 2 pieces of cheese, right? So without any overlap, you can fit 6 pieces of cheese in the 10x4 grid, and the answer is 6, all right? And it's the same for the other ones. So here you can fit 4 pieces of cheese in the grid without any overlap, and the answer is 4. And in the earlier one, you can fit 4 pieces of cheese in different locations, but they always overlap. So you can only fit in 1 piece of cheese without overlap. Okay, so let's solve this. So I'm in a terminal here. This is my home directory. Like think of it like the desktop. And I'm going to change directory. Think of that like clicking on a folder to work, informatics, and I've created, I forget the name, it's called AIO practice, but you can see my informatics directory has a lot of things in it. So cd AIO practice 2020, right? And there are some files in the take 1 directory that I did yesterday, but I'm starting from scratch here. So I'm going to create a file called problem1.py for Python. Over here, I'm going to run a Python REPL. It just means that I can type any Python code in here that I like. Oops. Okay, so it's going to be an error. The length of that string is 6. Okay, and I've just got another little window here in case I need it. Okay, so I'm typing an answer now. Right, this is problem 1. Sandwich holes. Okay, so I need an input file and an output file. So I'm going to create them here. In and out equals open. And it's called holesin.txt. That's my input file, and here's my output file. Holesout.txt, and I need to signify that I'm writing to that file. And just to demonstrate that I can write to a file, I'm going to say print hello and file equals out. And at the end of my program, I'm going to close both of them, close the files. Okay, so if I run this, I'm running it, and I've got an error. Right, so no such file or directory holesin.txt. So I'm going to create it over here, holesin.txt, and I'll just mimic the first. Mimic the first thing. And if I run this again, so if you try to open a file for reading and it doesn't exist, then you get an error. All right, so nothing happened, but now if I go over here and I can look at holesout.txt and it says hello, because I printed hello to that file. Okay, so now let's do something a bit better than that. So, all right, so we're going to read the input file. Okay, I'm going to do this in a really basic way, just to show you the absolute basics. So I'm going to say line 1 equals in dot read line, and line 2 equals, well, the same thing, in dot read line. So I've read 2 lines from the file, and I'm going to indicate over here what they are. And you know what? Oops. I'm going to do the better example. So the 10 by 4 sandwich and the 3 by 2 cheese. Okay, and that's got an answer of 6. Right, so reading a line just gives me the string, you know, the characters 1, 0, space 4. That's no good to me. I need integers. So if I go LW, so length and width, equals line 1 dot split, and now I've got 10 and 4 as separate strings, right? A, B equals line 2 dot split. I've got 3 and 2 as separate strings. They're still no good to me. I need them as integers. So I go LW equals int L and int W. So now they're integers 3 and 2. Oops. 10 and 4. Okay, and then A and B equals int A and int B. That's 3 and 2. So I've got LW, A, and B now. Now I could do that so much better, but I'm just showing you the absolute basics so that when I do it better later on, then you'll see how the basics are being put together. Okay, read the input file. All right, so calculate the answer. Okay, so the horizontal pieces that we can fit in is it's the length of the sandwich, double divide A, and the vertical pieces that we can fit in is the height of the sandwich, double divide B, and the answer equals the horizontal pieces times the vertical pieces. Now let me just demonstrate. You would have seen this before. 10 single divide 3 gives you a decimal. 10 double divide 3 is integer division, ignoring remainder. If I want the remainder, I go 10% 3, and there's the remainder. Okay, so 3 goes in 3 times, remainder 1. So this is how we work it out, and I've got the answer. And now okay, so to write the answer, I'll just go print answer, comma, file equals out. And I like to print the answer to the screen as well, so I can just see what it's calculated. Okay, and there we go. So if I run this now, then there's a H that I haven't defined. So this, sorry, this is it's the width, not the height. Okay, answer 6. If I look over down here, then it's holes text, and it's just got 6 in it. That's what the website will be looking for the correct value to be in the output file. So I can submit this now. It's saved. So I just go back to here and go submit a solution. All right, I'll just go choose file. Double click problem 1, and it's picked up that it's Python 3, and I'll go submit. I'll just take you through what we're seeing here. So we've got a current score of 0 out of 100. You can submit as many times as you like, so you're not limited to just one go at it. and it'll get marked then and there, and it'll tell you what your score is. Okay, if using Python, make sure you choose the correct version of Python. If using Java, well, we're not. Remember to submit source code, not an executable file. Well, we can only submit source code if it's Python. Make sure you're reading from and writing to the specified files, not standard input or standard output. So you're not printing your answer to the screen, you're printing it to a file. That's the fact they've put that in bold means it's a sticking point for many beginners. Okay, so when I press submit, it's going to do evaluation. Right, it says compiling, so it's sort of processing my source code and turning it into a program. Okay, submission has been received and is being evaluated. So it's being evaluated, and we've got a score of 100 out of 100. Okay, lovely. If I click View Details, then there are all these subtasks, which is kind of irrelevant for this particular task. So I think I'll delay talking about subtasks to the next one. But it tells you about how much time and memory, so on. Right, so hard to know what to make of this. Like, we only really did very simple stuff, simple calculations, reading and writing to a file. I don't see why it would take 40 megabytes, but that's life. Okay, so we'll go on to problem 2. So it's going to download that. Download task statement. So bracelet jewels, this one's called. It's a nice problem. Okay, so here's the problem. Once again, zoom in, and I'll be quiet for a bit while you read the statement. Okay, so after reading this, for the first time yesterday, I admit I had a bit of difficulty understanding what it was on about. So that's why they have sample input, sample output, and some explanations. So the 10 means that you've got a string of gems in a circle that are red and blue, according to this. And the output of 6 means that the largest possible combined number of gems you can get is 6. So there's a diagram on the next page. So here they are: red, blue, blue, red, red, blue, 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 red, red is what was told to us. And if you make the cut here, then you'll end up with these 3 reds at one end and these 3 blues at the other end, and that's what you'll be given. Okay, so it's very, obviously it's very contrived, but it is an interesting little problem, finding the maximum thing meeting a certain condition. Okay, so there's an explanation here. For sample input 1, cut between the 8th gem and the 9th gem, and whoever will give you 2 bracelets with 3 blue gems and 3 red gems respectively. I'm not going to look too much at the other ones. Now let's have a look at this more technical information. So the constraints. The number of gems is between 4 and 100,000. So obviously we need a pretty efficient way to process this, because if we have an inefficient algorithm, then it won't complete on 100,000 gems in time. Subtasks, we didn't talk about subtasks last time. They're meaningful this time. So there are 5 subtasks with a differing number of points. You don't get any partial points, right? So you either get 25 or 25 plus 20 or whatever, right? I could solve subtask 3 but fail on, on subtask 4. It'd be very unusual to solve subtask 3 but fail on 2 and 1. But anyway, what a subtask is basically a way of making it easier, potentially. So in subtask 1, there are only 4 gems, right? There are only 4 gems, and so that means there are only 16 possible inputs, and you can, if you want, you can work out all 16 inputs and their corresponding outputs yourself, write a program that just looks for each input and gives the correct output, and you can get 25 points, right? Subtask 2, we're not told how many gems there are. We're told there are exactly 2 red gems and they are not placed next to each other. And so if you wanted to think about that, and it says that sample input 2 is an example of this, if you wanted to think about that, you could maybe go, oh, well, if that's the case, then all we have to do to solve it is this. Okay, I'm not going to do that. I want to do a general solution. But if you're doing a problem that is generally quite difficult, then you can look at the subtasks to see if any of them are easier than the general problem. For subtask 3, we've got n is less than or equal to 1,000. So that means that an inefficient algorithm could probably still work. For subtask 4, you're told that no 2 red gems are placed next to each other. Okay, I don't care about that. And for subtask 5, there are no further constraints. So the only thing that applies is this, and the gems could be arranged in any way at all. So once again, for this problem, the subtasks are not meaningful to me, but for another problem they could be. Okay, so I'm going to stop editing this one and edit a different one, so problem2.py. But I'm going to read in, my earlier one, problem 1, because I can reuse some of the things. Now, what's the file name? JoulesIn.txt and Joules out. Actually, what I'm going to do is say name equals Joules, and then trying to make it easier for myself, and I'm failing. And let's see if I can get it right this time. Okay, that's better. So now that'll give me JoulesIn.txt and JoulesOut.txt, and I don't need to, I can just use this each time. Okay, read the input file. I'm going to do, I'll do what I need to do. Calculate the answer. Well, that code doesn't work, but then, yeah, all of that code here, writing the answer and closing the file, that's still what I need. So to read the input file, well, n is, now what I do, read line, okay, but that comes in as a string, and I want an integer, so I'll just convert it to an integer straight away. And the series of gems, which I'll just call data, is in read line. So that would give me like the red, whatever. Okay, and if that was all, then that's fine. I could make it a list if I want, but for my purposes, I'm happy with it as a string. But the problem is it's going to have a new line character on the end, almost certainly. And so I can get rid of that by calling the strip function, and then that will get rid of any white space on either side. So, okay, so that gives me what I want. All right, so I've got the number of gems and I've got the data. Okay, now to calculate the answer, let me talk you through a good algorithm here. So if I've got, let me take RBB. All right, so I've got RBB, RR, BBB, RR, and just to demonstrate, the aim here was that you cut it there, right? And then the idea is that this R can join those R's, and then you've got the BBB and the RRR, so the shop owner will cut it there and give you those two things, leaving that out, and hence you get an answer of 6. Okay, so the trick is that the gems wrap around because it's given as a line here, but really it's on a circle. So that R really does join up with those. And so what I'm going to do is take that, and if I just make 2 copies of it, then if I make 2 copies, then now I've got the 3 R's together. And basically I'm looking for the answer amongst this without having to think about wrapping around. And so that's nice. All right, now that I've got that, well, I'm just going to count I'm going to count a 1 there and 2 there and 2 there and 3 there and 3 there and 2 and 2 and 3 and 2. Okay, so I'm counting how many similar things there are together. All right, and sorry, that one should be a 3 because there are 3 R's together. And our answer comes from this. The 3 plus 3 gives us a 6, right? So basically what we want to look at is the sum of neighboring things. So 1 plus 2 is 3, 2 plus 2 is 4, 2 plus 3 is 5. All right, that one's 6, that's 5, that's 4, that's 5, and that's 5. Okay, and the maximum, and that's the answer. Okay, so that's the algorithm I'm going to use. I'm looking for groups of like things, and then I want to know what's the best pair of groups that are consecutive. Okay, so what I can do is I'm going to write a little description here. So put 2 copies of the gems end to end. 2, count consecutive. Wording things can be the hardest, right? So that's why I started with the example first. But how do I describe what I've done here? Okay, so produce a list of group sizes of like gems. Okay, so blue, 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 blue gives you 4. Or blue, 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 red, red gives you 4, 2. Okay, so it's just to clarify. 3. Now, produce list of consecutive sums, previous list, and for select maximum. Okay, so I've outlined what I'm doing. I'm going to that's all a comment now, so it gets ignored. But I think that's useful. Oh, this is part of the comment. Okay, so I can actually do those 4 things in 4 lines of code. So I can say data equals data plus data. So that's put 2 copies end to end. And then to produce the group sizes of like gems, I can say, let's say group sizes equals calculate group sizes, and then sums equals calculate consecutive sums, and then the answer is the maximum of sums. All right, so Python can find the maximum of a list for us. So there's 4 lines of code that match the 4 lines of algorithm description. Problem is, Python doesn't know what I'm talking about when I say calculate group sizes, so I need to create that. So def calculate group sizes, and I need to calculate consecutive sums. Pass is just a way of telling Python that I'm not going to implement it yet. So I don't have an empty function. It's a deliberately empty function, if you like. Okay, so it looks at data, right, rather than the function getting an argument. It's looking at the global variable data, and so data equals. So what's our R? Oh, let's see. Let's use this. So this will give us the answer. Okay, so we've got the 1, 2, 2, 3, 3, 2, 2, 3, 2. Right. That's just a little comment to say what I'm trying to produce. And while I'm at it, this calculate consecutive sums needs a list. And this one is 3, 4, 5, 6, 5, 4, 5, 5. Right, just from my what I have up here. Okay. Right, so to calculate the group sizes, what am I going to do? Well, I'm producing a list, right? And so the result is going to be a list. So I'm going to start with an empty list and build up. And in fact, let's just say if data is an empty string, we'll return an empty list. Data should definitely not be an empty string, but if it is, so if we now know that data is not empty, then I can say the result is a list with 1 in it. And let me explain. We know if it's not empty, then there must be a character at the start. In this case, it's R. And so there's 1 R. And then if, let's say, I'll delete these in a minute, but if there were a few R's at the beginning, then I'd go through the list starting here and say, well, that's the same as the previous one, so I'll up that 1 to a 2. That's the same as the previous one, so I'll up that 1 to a 3, up that 2 to a 3. And then it goes up to a 4, and then we get something that's different. So we start a new, like we put a new 1 on the list of result, right? I wish I could show this on a whiteboard, but I hope you get the idea, right? Then that 1 would go up to a 2, and then, oh, we got a new one. So the result list would look like 4, 2, 1 at the moment, then 4, 2, 2, then 4, 2, 2, 1, 4, 2, 2, 2, 4, 2, 2, 2, sorry, 4, 2, 2, 3, and so on. Okay, so get rid of those. Right, so the result is 1. And now we're going to look through all of these. So I need to go through it by index, I in range, starting at index 1, because I've already considered the first thing at index 0, and I go up to n. And basically, there are 2 possibilities. So if data I is equal to data I minus 1. So if it's equal to the previous thing, then just putting the pass in because, right, that's the structure, right? Either that happens or they're not the same. So if they are the same, okay, so same as previous, so increment current result, right? So result is a list, but we want to increment the last one in the list. And this one, we have a new group, so a new result. Okay, and so we just go result.append and we put a 1 in there. Okay, and so that goes through the list, and when we finish the for loop, then we just return the result. Okay, so I can run this now. What I'm going to do is just put some dummy data in here, right? 1, 2, 3. I need to put return in. Okay, I can, if I actually run this, then there's no, okay, so I don't have a cat Jules in text. So, sorry. Cat Jules in text means read the file, but if it doesn't exist, this means create the file. I'll explain all that another day. So if I have 10 and I'm following the R, B, B, R, B, 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 R, oh, no spaces. So edit that. So watch this. I'm going to, on the current line, I'm substituting anything that's a space for nothing, and I'm doing it for the whole line. Okay, done. Right. So now I can run this, and sorry, before I so I'm going to print the group sizes. And there they are, 1, 2, 2, 3, 2. I've got a pass that in. Now 1, 2, 2, 3, 2 seems quite short because that's like I haven't doubled it, but I have doubled it. So I wonder why. So I've got, oh, I know why. Oh, silly me. Okay. So that when the data came in, there were only, it was only 10 digits long. And then I did this, data equals data plus data, right? So now it's 20 digits long. But look in here, I only go up to n. So instead of going up to n, I'm going to go up to the length of data, right? Rather than assuming that n, that's the correct value. Okay, so now the group sizes looks better, and I just need to correctly implement calculate consecutive sums. So what I'll do is now once again, the result is a list that I'll start from scratch this time, and I'll say for I, same sort of thing. I start at index 1. I go for the length of the list, and I wish I could use sum, but that's a function already, so call it total equals the x's I plus x's I minus 1. So I'm starting at index 1, right? And I'm looking at x's 1 and index and x's 0. So I'm adding the 2 and the 1 to get 3, and then I'm going to pop that in my results list. And then next, I will be 2. So I'm at index 2, so I'm adding the 2 and the 2, and I'll get 4. And I'll be adding the 3 and the 2 and get 5, and so on. Okay, so I've got the total, and I'll just say result dot append total. And then when that's done, return result. Okay, and I'll print the sums. Okay, and the answer is max sums, so that's easy. Right, and so I'm getting the answer 6 here. So I reckon we've got a pretty good program here. All right, I'll get rid of that. Right, so I've got my 4 lines of actual algorithm, but the details to some of it is in these functions. And you saw how I can test the functions separately, which is nice. This one here would be a better function if I passed in the data instead of operating on the global variable, but we've got to be a little pragmatic, I suppose. Okay, well, I'm going to submit this, see how we go. So submit a solution. Part of the reason my computer's slow is because of the recording the video. Right, so that's problem 2. It knows it's Python. Let's submit and see how we go. Now, if it seems like it takes a while to evaluate, that's because it's probably testing it with about 100 test cases. And each one has to load the program and then run. Okay, got 0 out of 100. I hope that seems like a surprise to you because our algorithm was looking pretty good. It's not a surprise to me only because I did this yesterday. It was a surprise to me when I was at this point. So let's see. Okay, so all red here, not looking good. But what you can see is that some of the things are correct, right? In fact, a lot of them are correct. And so you might think, well, why don't you get some marks? Well, subtask 1, I have not solved subtask 1 correctly because I haven't solved it correctly in all cases. So I don't get the 25 marks for subtask 1. So the details. Your problem did not finish successfully. Return code non-zero. I'll talk about the return code another time. Possibly due to an exception or error being thrown. So what it's telling us here is that it's not a matter of getting the wrong answer. It's a matter of the program crashing. And it's really nice how we can see that in sample 3 that it wasn't successful. So that means I can look at what sample 3 was, and I can put that in my program. So it's where it's all blue, right? So I wonder if you can predict before I Jules. Before I run it, Can you predict why it's crashing? Okay. So let's see if I run it here, does it crash for me? Yes, it does. All right, this is all the previous run. So here we go. So it's saying the problem is getting the maximum of sums, but the max argument is an empty sequence. So if I put, okay, now I know why this is, right? And perhaps you do too. But once again, like printing the, doing a bit of print debugging, we call it. So even though it's going to crash, I'll get some printout on the way. So the group size was 8 because we had 4 blues and then we double it to get 8 blues. And then there's only one group, right? So if there's only one group, then the consecutive sums, like you can't compare index 1 with index 0 because there's only an index 0. So we need to basically just see if the group sizes, we want the length of the group sizes equals 1. So if there's only one group, then our answer is going to be n, right? So it'd be 4 in this case. Else we do the normal thing. Okay, so I've saved that. I'm going to submit again. Well, this will take a little bit. This one should get 100%. Don't know why it's clearing the screen. Okay, compiling. Right, hoping for 100% here. So this was intermediate content. Right, the first problem was really easy, simple calculation. I'm not saying it's really easy for a novice to do. I'm just saying when you've got a bit of experience, there's our 100%. When you've got a bit of experience, that first problem is just one calculation. That's it. All right, this second problem, we've got some data we have to look at. Like we have to look at all those R's and B's and make a decision about where should we, cut the string, or how many. What's the biggest group of things we can get? Not only is that's much harder than problem 1, right? And not only that, but it would be possible for some people to try all sorts of algorithms that really do far too much work, and so they wouldn't get 100% for that. Okay, so that's done. Problem 3 will be the last one we look at today.